Yes. So after this, you're going to have many tools available to solve using trigonometry, okay? So for Pythagorean theorem, that was grade 9. All you did was side lengths in a right angled triangle. Yesterday we did SOHCAHTOA, or the sine ratio, cosine, and tangent ratio. And they have to do with trying to find the relationship between angles and sides. Then we did the sine law for a non-right angle triangle. When you know a side and its corresponding angle, or an angle and its corresponding side, you can think of it either way. But what happens when you don't have a complete ratio, when you don't have a side and its corresponding angle? Then what we can use is something called the cosine law. So here, if you try to do a complete ratio, so if you want to let's write in the sides. So side A is 45, B is 62, C is 40. So when you write out the sine law, and because we don't know any of the angles, I'm going to use the angle form. So I'm going to put the angle at the top, but it doesn't matter, okay? Can we use the sine law to solve for any of the angles? No, we don't have a complete ratio. In this one, so this is FMT, that's wacky letters. The reason we're going to use these weird letters, because maybe when we do the word problems, kind of like yesterday, sometimes you might label it like P for pilot, A for airplane, or whatever. So you might not have alphabetical order, but you're still going to do the same thing. Look for the opposite side. So 80 degrees is angle F. The opposite is side F. T is blank, but side T is 8.5. M also blank, but side M is 10. So now we do have an angle, but we can still try to do the same thing. So here, even though we have one of the angles, we don't have its corresponding side. And we don't have two angles, so we can't solve for the other one using the interior angle relationship. So what do we do? How do we fix this? So we're going to use what's called the cosine law. So in a situation where you have all the side lengths, no angles, we call that side, side, side. And when you have a side and a side, and we call this the angle between them, or the interior angle, we call that side angle side. So next year, the labeling a triangle side, 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 angle, side, you're going to look at a case where, again, your calculator, you can kind of punch it in, but the number it gives you actually doesn't make any sense. You have to manipulate it. It's called the ambiguous case. So labeling a triangle or figuring out what kind of information you're given is going to be sort of the next step in what you're going to do next year. So it does have, on this slide, it does have the two relationships we're going to use, side angle side and side side side. Usually in grade 10, what you're going to do is fill in the information you know and then just go from there, okay? So if you struggle sometimes with whatever kind of math problem, you're like, I don't know what to use, then one of the strategies you can use, and you'll have to be patient with yourself, is once you recognize that it is not a right angle triangle, you can try to use the sine law, and then when you don't have a complete ratio, then say to yourself, okay, then I have to use the cosine law. It's not going to say use the sine law to solve this triangle, use the cosine law, use SOHCAHTOA. You have to figure that out, okay? And then obviously we're going to do word problems as well, so maybe you even have to draw your own triangle, okay? So here we have unfortunately for the cosine law, there is 3 versions, and they are a little bit trickier than the sine law. So that's why if you can use the sine law, you should try to do that first. It's much easier. So it's related to the Pythagorean theorem, but of course it's not a right angle, so we have to take that into account. So you're going to get, I forget what version it is, but one of these versions. So what you're going to do is possibly have to write your own. And in a second, we're going to do QRS. Okay, so I'm going to show you how it works. So you have, in this case, let's change this to A, B, C. Okay, so what side are we looking for? That's what goes on the outside, okay? It's the only side we don't know, okay? And then it's kind of like a sandwich, okay? So then if you have that side, then over here, it has to be the angle. So we have side A at the end is going to be angle A. Now, also, the only angle we know is angle A, okay? So you have to know it. And then the 2 in the inside, or the side, are the sides that we know. So b squared plus c squared, we know side B. Pick a different color if you have one. And we know side A, not A, sorry, C. So b squared plus c squared, we have to know those because we don't know A, minus 2 times b times c times the cos of the angle we know, which is angle A. So the outside ones are the same and the inside ones are the same. So if we were looking for side B, that means that we would know angle B, a squared plus c squared minus 2ac. If we're looking for side C, then angle C we would know a squared plus b squared minus 2 times a times b. So unfortunately, last year, if it's in your brain that that side C has to be the hypotenuse, that is going to kind of mess you up here because there is no hypotenuse. Okay, so you really have to look for labeling the vertices and then doing the across thing. This is angle C. Across from it is side C. Angle A, across from it is side A. Yes. 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 Okay? So what you can do for the side, or the angles, sorry, is you can give, like I'm going to give you this. To be honest, this to me is just a rearrangement of this. It might make more sense to you to plug in what you know and rearrange it without rearranging the formula first. But you can do that. So it's the same sort of thing, except it is a little bit trickier. So I'll give you, I think it's the A form. So A, the angle A is like the one you're looking for. So if you want to make that orange, goes first. So it's A squared minus BC squared over 2BC. Okay, but this is sort of nasty. You can use this form to do this as well, okay? All you would do is plug in everything. You would know the three sides, and then you would have to do the cos inverse to get the angle, which you guys are already used to doing. So yes, I'll give you this, but plugging stuff in and just going through the algebra like you would before might make more sense to you, okay? I include this, other teachers include this, but really, to be honest, I think it's easier to rearrange because you're already used to doing that. But I'll give you this form too, okay? So we're gonna do two examples. We'll do a side, 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 and a side angle side so that you can see the difference. Okay, so for triangle, QRS, set up the cosine law. So now we're going to do it just to get you to practice without worrying about if it's A or B or whatever. Okay, so make a triangle. Make sure it's not a right angle. Again, in English, it's hard to tell the difference between big S and little s. So whatever your big S is for the vertice or the angle, then make sure your side S is little, okay? So the general form, or the form that you're probably going to be given, is this. So you have to be able to manipulate it to whatever you want. So it says to find or write the cosine law for side S. So we're going to put S squared because that's the side we want, little s. Side. When you have squaring and adding, does it really matter what order you do it in here? No. Most people will, want to write alphabetical order, but if you're not good at the alphabet, don't worry about it. It doesn't matter. Same thing with multiplying. It doesn't matter the order. And then cos. What angle am I going to use? S. So I tried to exaggerate my big S there. Okay, yes. That is the general form. It has to do... Yes. Sure, you can. Doesn't matter. This means multiplying. If that doesn't make sense to you and you want to put it in brackets, that's fine. Okay, so again, when you do the angle, it is a little bit gnarlier to try to figure it out, but you can do it, don't worry. Or you can plug in the numbers into this form and just rearrange. Okay, so it's really up to you what you want to do, because you'll probably be given it in generic ABCs, okay? So we're looking for A here, but we're asked to find R, so that's the angle we want. Just like the SOHCAHTOA, just like the sine law, when you're looking for an angle, you're going to do cos inverse, right, to get the angle. And we want, so this matches the first one. So we're going to write R squared. And then it doesn't matter which one you subtract first, but we'll go alphabetical just like we did up there. Q squared minus S squared divided by 2QS. If you wrote S and Q, that's fine too. It'll work. Okay? So we're going to do an example. It says to solve the triangle. Once we have to do cosine law first, but then we don't have to. However, I'm going to do cosine law for both cases just so that you can see the difference, okay? And then really once we have a complete ratio, you could do the sine law. If it just says solve, then and it doesn't say you have to use the cosine law or whatever. Once you have a complete ratio, if you want to do the sine law, that doesn't matter. That's fine. But when we do this example on this note, because it is the cosine law note, we're just going to use cosine law. Okay? So it says solve triangle ABC. So similar to the other questions, it gives us what the points are, the vertices, or the angles. We have to label the sides. So 17 is A. 28 is B. And then this is side C, which we don't know. So do we have side C and angle C? No. Do we have side A and angle A? No. Do we have we have angle C but not side C. And we don't have angle B and side B, we have just side B. So there's no complete ratio. So this is called side angle side, or the interior angle between two sides. So we have to use the cosine law. We can't use the sine law yet. Yes. Yes. Even if you get a question and it gave you A, like if this wasn't here, but it gave you A, you could figure out what B was and then use sine law. So if the question just says solve, then try to use the sine law first. It's a little bit easier. But this time, for both side C and then one of the angles, I'm going to use the cosine law. Technically, once we find side C, then we can use the sine law, but I'm not going to. Yes. Sometimes we call it corresponding. So the angle and its corresponding side. Okay? So one of the things you can do, if maybe it's not obvious to you the side angle side, you can try to write out the sine law and it's not going to work. So you could write out, we don't have that. Nope. Oh, I'm lying. We have 17. Okay, that's not full. All right, no big deal. Let's try B. No, that doesn't work. So you can try to do that. Notice, no full ratio, so you can't use sine law. You don't have to do that. You don't have to. But if it makes more sense to you to try it out first, then you just have to be patient with yourself, okay? Because it's going to take you longer to do a question. So again, you might recognize this as side, angle, side, which is a sine law or a cosine law thing. Oh, yeah, sorry. I don't know why I wrote it like that. Doesn't matter. Doesn't work anyways. Sorry. And now it's up to you as well. So if, let's say it's a test or the exam, if you're given the form of the cosine law with A on the left, and you have to write that out first, and then we're going to adjust it to side C. It's up to you, okay? But we have to use the cosine law because we have side, angle, side. So we want to find side C. What's left? A and B. And then the only angle we know is angle C. So it's like a C sandwich. Every time. You can put them, it doesn't matter. It's understood to be multiplication. If it doesn't stand out enough to you, put the brackets. It is kind of one big thing though. You want to do -2 times 17 times 28 times cos 52 before you you know what I mean? It's kind of like the discriminant, right? You had to do all of that math, or the -4 times A times C, right? So again, you have to decide kind of relationship you have with your calculator. You can definitely do this as one step. However, that's not my recommendation. If you don't like that kind of thing, the more work you show, then if you get the wrong answer, I can give you part marks. So 17 squared is 289. 28 squared is 784. -2 times 17 times 28 times cos 52. So when numbers are written like this, that means multiply, right? Okay. Is -586. I'm going to round. It's a repeating decimal. I'm going to choose 4 decimal places. It doesn't really matter. So 289 plus 784 minus 586.1097 is 486.8903. So similarly to grade 9, when all you had to do was the side length and a right angle triangle, and it was the Pythagorean theorem. Don't stop here, right? You've done all the hard work. What should you do as your last step? Yes. Good. Square root both sides. Okay, so you can write it in if you want as you go along, because now technically you have a complete ratio. You have side C and angle C. Um, but I'm not going to use the sine law here because I want to use the cosine law, okay? And it actually really doesn't matter because we have side A and side A and side B. What angle would you like to solve for first? A? Let's do it. Can you go over? Okay, clear it out. Doesn't matter about the negative, but put it in. Do negative 2 times 17 times 18, and then put brackets, and then do cos 52. And then do bracket, bracket. Oh, no, you don't. Oh, you wrote 18 and it's 28. That's why. Okay, so now we're going to do, what I'm going to do here, I'm going to show you the weird angle formula. And then I have a little bit of room down here. So what I'm going to do is actually show you another way you can do it, where you can use the same-ish form of the cosine law every time if you would prefer. Okay? So now this is a squared minus b squared minus c squared over 2bc. And remember, just like all, whether it's SOHCAHTOA, the cosine law, sine law, whenever you're finding an angle, you're always going to have to do the inverse to find what the actual angle value is. So let's write that in. So now for B, you can just subtract from 180, okay? Yes. Yes. Because this is the cosine law note. That's why. And I want to show you both. But I don't care what you do. Okay, so another way you could have done A as well, um, you can, if this seems way too gnarly for you, then what you can do is you can always use this and then just rearrange. So we know what A is. Okay, so 17 squared is 289. 28 squared is 784. 22.1 squared is 488.41. Then this, so then you would just collect like terms, like bring it over. And now you'll notice this is basically this, right? So you can plug the numbers in and rearrange as you go, or you can use the rearranged formula. It actually doesn't matter. Right? So then you would divide and do the cos inverse. So now it looks exactly like this. We've just done it there in the black as one step. So decide what you want to do, which you prefer, because you should get the same answer, which we did. So Kyle, there's something on the floor. Is it Phillips? Philip, why is your garbage over there? Thank you. Okay, so you have to look, is it a right angle triangle? Yes, then you can use SOHCAHTOA. You can use Pythagorean theorem if you know all the sides. And you know two sides, you're looking for one. If it's not a right angle, then you want to, can you fill in a ratio? So try the sine law first. Do you know an angle and its side? If you don't, then you have to use cosine law. So if you have all three sides or an interior angle, the angle between two sides, then you have to do side angle side, okay? So what I'll do is I'll put up the D2L chart, so all the homework as well as the test review. So when we have to do word problems after lunch, but in case you happen to finish this cosine law homework and you want to start on the review, I'll put that up there.